Hello and welcome to Quantitative Technique videos at edupediaworld.com, your favorite portal for online education. Continuing our study of the time series analysis, today we shall take up an important method of determining the secular trend, and that is the moving average method. For the past couple of sessions, we had been seeing the time series analysis, and we had seen some of the methods of measurement of secular trend. To begin with, we saw the graphical method. Thereafter, we moved on to the method of averages and took up the selected point and the method of semi-averages. Moving average method is another method under the category of method of averages. Today we shall see the basis of this method, how do we work out and how we find the value of the trend using the moving average method, and thereafter we will take up a problem to consolidate our understanding. So here we go. First, let us understand what basically moving average method is and how we proceed to find the value of the trend. In the moving average method, what we do is we take a group of data from the given observation. We take a fixed group of data and we find the arithmetic average or the arithmetic mean of that group. Thereafter we move on, we take the next group, which is taken by eliminating or by leaving out the first value of the first group and including the next value in the series. In the same way, we continue and we calculate the arithmetic mean of the overlapping groups of the successive values of time series. Each group includes a given number of data from the given time interval, and we call this group as the period of moving average. As I said, the next group is obtained by replacing the oldest value by the next value in the series. So this way we proceed and we find the averages of all the subsequent groups, all the overlapping groups, and that in turn gives us the value of the trend. Before we take up a numerical problem, let's understand the principle upon which this method works. It's based on the principle that the total effect of both the periodic variations, that is the seasonal and the cyclic variations at different points of time in its cycle, gets completely neutralized. In other words, we can say that the short-term variation, the sum of the short-term variation in its period and the sum of the long-term variation, that is the cyclic variation in its period of cycle, is equal to 0. And the process of computing the moving average basically smoothens out both these fluctuations in the time series data. See, what basically happens is, suppose if there is a fluctuation and the fluctuation is for a time interval of say 4 or 5 period, for n number of period. Once we take the average of n numbers and we take subsequent averages thereafter by including a new data in each of the groups and eliminating a previous one, we get a set of averages which eliminates the fluctuation. And in case if the trend is linear and these oscillatory variations are regular, both in terms of its amplitude, that is in terms of the magnitude, and in terms of the time interval, that is the time gap, then what happens is that if the period is equal to the period of oscillatory variations, then that would completely eliminate them. If our period of moving average is equal to the period of oscillatory variations, both in terms of amplitude and in terms of the period, then this would completely eliminate the variation, provided the trend is linear. So this is the basic principle and this is the benefit of this method. Further, this method also eliminates or minimizes the random component or the random variation of the data. Basically, if there is a random variation present in the data and if we take a large value of the moving average, since we are averaging the values, the fluctuation or the variation present would be minimized. Fine. And if we take larger moving period, then the effect of reduction will be more in the random component, but at the same time some information would be lost at both the ends of the data. Say for instance, if we take a 3-period moving average, and if we find the average of the first 3, we would center it to the second time period. Therefore what happens is that you will have no data, no trend value for the first time period. Is that clear? Yeah. In the same way, if we move on and if we take the next 3, leaving out the first one and including the fourth one, we will have the value which would be corresponding to the third time period. So we will have values from second, third, fourth up to the penultimate value, and 3-period moving average is the smallest moving average which we can take. Okay, here also you're losing 2 data, one in the beginning and one at the end. So likewise, if you increase the time period, you will be losing out on more data. For example, if you take 4-period or 5-period moving average, you will be missing out on the first 2 and the last 2 periods. Okay, so let's move on now, and before we take a problem, let's take the table and try to understand why. Because the treatment of moving average for odd moving average, odd period and even period is different. Why? Because the moving average of a group is always shown at the center of the period. If the period is odd, we can easily show it at the center, which corresponds to the second value. If it is 3, if it is 5, it would correspond to the third one. Okay, but that's not the case with the even moving period. Okay, so when the period is even, the computed average will correspond to the middle of the 2 middlemost periods, that is to the second and to the third, in between the second and the third period. What we will have to do is we will have to center it to any one of these values. Therefore we will have to take 2 values, that is one which is at the which is between the second, let's say if we have taken 4 time period. Okay, so the value would correspond to between the second and third, and then for the next group it will be between third and fourth. We will have to take both of these and find the average and then center it to the third time period. We'll see this very shortly. Okay, so again you have to take arithmetic mean twice. Now here you have the time period, the table for odd time period, that is for 3-period moving average. You see here in the first column we have the time period given starting from 1 up to n. Then we have the value of the variable y from here, from y1, y2 up to yn, and finally in the third column I'm calculating my 3-period moving average. Okay, so the first 3-period moving average value would be y1 plus y2 plus y3. I'll take these 3, the first 3 values, add them and divide them by 3. Okay, and this would correspond to the second time period. Why? Because that is the center of this first group. Moving ahead, I'll take my second group with time period 2, 3 and 4. Okay, so the value would be y2 plus y3 plus y4 divided by 3, and that would correspond to the third time period, which is here. So here we have y2 plus y3 plus y4 divided by 3. In the same way, when I proceed to the next one, I'll exclude y2 and I'll include y5. So I'll have y3, y4 and y5 exactly divided by 3, and that is to be written in front of the central value of these 3, which is 4. So this would correspond to 4. Okay, so for an odd period it's really simple. Moving ahead, let's understand the working of an even period moving average. Here again we have the time period in the first column. We have the values of y here in the second column, the variables y1, y2 up to yn, and here I'm calculating the 4-period moving average. So the first one, when I take the 4 values, it will be y1 plus y2 plus y3 plus y4. All of these 4 would be added and divided by 4, and that would correspond to the area between, or the time between, the second time period and the third time period. Okay, in between these two. Now this we see is not corresponding to any of the time period directly. Okay, so in the same way we'll proceed. We'll leave out the first one for the second group, second time group moving average. We'll leave out y1. Now we will have y2, y3, y4 and y5. We'll take the sum of these four and divide them by 4, and that would correspond to the period between 3 and 4. Okay, so that's what we have here. Okay, let me mark these as A1, A2 and A3. Okay, now to center them, what I'll do is, again, I'll take the average of these two quantities, that is A1 plus A2 divided by 2, and that you see is corresponding exactly to the third time period. In the same way, for the next one, I'll take this quantity here plus this quantity divided by 2, and that's here we have A2 plus A3 divided by 2, and that corresponds exactly to the fourth time period. In the same fashion, we'll continue proceeding, and we will have up to the third last. We'll be losing out the data in the first two, as you see here. You don't have anything over here for the first and the second time period. In the same manner, you will have nothing for the last and the penultimate time period. Okay, so this is the working of a 4-period or an even period moving average. We'll take up problems shortly. Before going to the problem, let's just understand the merits and the demerits of this method. Let's begin with the merit. The first advantage is that it is easy to understand and use. Why? Because there are not much of mathematical complexities involved here. It's straightforward, simple, and you just have to calculate the averages. Next, it is objective. Unlike the previous methods where we saw that they were subjective method, and the same set of observation when applied or when worked upon by different people would give different answer. But here it's subjective, and different people working with the same set of observation will get exactly the same answer. Further, it's flexible. Flexible method in the sense that if a few more observations are added at the end, the entire calculations are not changed, and you just need to work with the new set of observations. For instance, you have the data for the past 10 years, you have worked out the moving average, and then each subsequent year, when you add up new data, you can just work with those new set of data to get the new trend values, and you don't have to do anything with the previous values. They remain untouched. Further, we have seen that when the period of oscillatory movement is equal to the period of moving average, then these movements are completely eliminated. And we have seen this that it is based on this principle. And also we have seen that it's possible to eliminate seasonal, cyclic and random components. In fact, one of the uses or one of the indirect use of this method is to eliminate these components. Now coming to the demerits, let's see what are the drawbacks of this method. First is that it is not possible to calculate the trend value for all the items of the series. Some information is always lost at its ends. We have seen this, that even if we take a 3-period moving average, we miss out 2 information, that is for the first time period and for the last one. This method can determine accurate values of trend only if the oscillatory and the random fluctuations are uniform, both in terms of period and in terms of amplitude. Okay, but we know that it's seldom so in reality, because there are fluctuations of all different kinds present in most of the data, and these fluctuations are never or we can say are very rarely uniform, either in terms of time period or in terms of the magnitude. Further, this will never give you correct values if the trend is non-linear. Okay, if the trend the trend present should be at least approximately linear, but again we know that it's not very practical. In most of the times we may not have approximately linear trend, and when the trend is non-linear, the moving average will not give you correct values of trend. Further, the selection of period of moving average we know is a difficult task, and a great deal of care is needed to determine it. Why? Because we know that it works on the principle where the period of the moving average should correspond exactly with the period of your fluctuations. But we know that the fluctuation do not have same period every time, and also there is no way to know what would be the period of fluctuation. Therefore it's very difficult, and we just have to assume a value, and we have to take a value in between, neither too big nor too small. So selection of period of moving average is again a difficult task. And lastly, like arithmetic mean, they could also be affected by extreme values, as we see that moving average is nothing but the arithmetic mean of the given set of data. So they are too much affected by extreme values. Okay, so now let's move on and take a few numerical problems. Here we have two problems. The first one is determine the trend value of the following data by using a 3-yearly moving average, and the second one is assuming a 4-yearly cycle, find the trend value for the following data by the method of moving average. So one we have is for 3 years and another we have for 4 years. So we have one even and one odd. We'll practice both one by one. Let's take the first one. For a 3-period moving average, we have the year given from 2001 to 2010, and then we have the production in tons given as our variable y. So now let's find out the value of the trend here for these data. Let's first find the 3-yearly moving total. 3-yearly moving total. First, since this is 3-yearly, I'll have to take the first 3 values, that is 26, 27 and 28, and this would be centered to the second time period, which is 2002. So here I have the sum of the first 3 values, okay, and this is my 3-yearly moving total. In the same way, when I take next, I'll leave out the first one, that is 26, and I'll have just 27, 28 and 30, leaving out the first data of the previous group and including the next data in the series. Okay, and here in the next column I can find the 3-yearly moving average or the trend value. 3-yearly moving average or trend. Okay, trend is denoted by the letter T, and that will be the sum here divided by 3. Okay, so let me drag this down now to the to all the cells. We will have data only till the second last value, because this includes the data from here 31, 32 and 31. We will not have anything in the last row. Okay, so these are my trend values, 3-yearly trend values. Very simple to calculate. You just have to find the averages and you get the values easily. Okay, in case if you are asked to find the graph of this, let's see how the graph of this looks like. These are the given data and these are the calculated value of the trend. Let's just check how it would be if we have a graph. Let's use a line graph, and here we have. Okay, just let me adjust it to the page so that you can see both the data as well as the graph together. Alright, so here you see this blue line represents the given set of data and this red line represents the 3-yearly moving average. Alright, so now here you see that this has more fluctuation, the blue one, the given value, and the trend value are more or less linear. And you see in the first one it's coinciding exactly with the given value. Second one there is it's slightly upward. Third one it's slightly downward here. Then the fourth one again it almost coincides. Fifth one is little upward, and so on. Alright, so this is the calculation of 3-yearly moving average. Now moving on to the next question, which is to find the 4 yearly moving average. Here we have the data of 14 years and the sales value given in all these years. We need to find the 4 yearly moving average. Alright, so let's go to our Excel sheet. Here we have the set of data. We have the years given here in this column, and we have the variable Y, which is in terms of sales, given in this column. I need to calculate the 4 yearly moving average. So first let me calculate the full 4 yearly moving total. Let me write it shortly as MT. Okay, when I take 4 years, I'm going to take the values from here: 74, 100, 97 and 87, all of these 4, and that would center to somewhere in between 2002 to 2003. That's over here. So here I'll have the sum of the values starting from the first one till the fourth value. Okay, that's my first the sum of the first four data, first group. For the next group, I'll exclude this 74 and I'll include the next value, that is the value for 2005, which is 90. Okay, so here next value would be here, and that would be the sum of the values from here, 100 till 90. Okay, the same way I can do for others. Next, I need to find the average of these. Okay, average, or you can write it as 4 yearly moving average. Now this is not your trend. Okay, this 4 yearly moving average value is not exactly your trend. Why? Because they are not centered and they do not correspond to a year. We will have to do one more step, just bear with me. So here what I'll do is I'll just take this data and divide it by 4 exactly. Why? Because we added 4 values to get this. Okay, so here now we have this the average of 4 years, but we see that they're not centered. Let me first drag it down to all the cells. We will have it up to the value here. Oh, well, we'll not have the values in these columns. Let me redo it. We will have it in between all the years. So let me just copy and paste this formula to all of these cells. Okay, so now we have the data for all in between. The last one, if you see, we will have from here 118 up to 126. We can't proceed any further beyond this. Now coming to the centered value, and the centered value actually will be our trend value. To center, we will have to take these two data and add them and divide them by 2. So it is the sum of the value here plus the value here, and that would be divided by 2. This is our centered value, and this in fact is our value of the trend. Let me now use it in all these cells. Okay, so these are our trend values, which are represented in this last column with red font. Fine, so now you see that we are missing the value for the first 2 years, that is for 2001 and 2002. At the same time for the year 2003 and 2013 and 2014. Let me mark them with a different color here. You see that these data have gone missing. So this is the method of calculating for 4 yearly or for even moving time period. Okay, hope it is simple and clear. Now if you want to look at the graph of this, we can easily get the graph here in Excel. Let's see how the graph of this particular set of data looks like. We have the given data and we have the trend values. Let me insert the graph here. Alright, so you have the graph. Well, So the one in red is your trend value, and the one in blue is actually your given data or given series. Alright, so now let's move ahead, and for practice let me give you a few more questions, a couple of questions for practice. Here you have the third question for today, where you are asked to estimate the trend value by taking 5-yearly moving average. Remember, this is again 5-yearly moving average from the given data. Graph the original and the trend values and thereby show that on that portion of the curve which is concave from below, the moving average curve lies above it, and then on the portion that is convex from below, the moving average curve lies above it, and on the straight line portion of the original curve, both coincide with each other. So when you graph, you will see that these points are obvious if your answer is correct. So find the values of the trend for this given set of data. You have 17 years data, and you need to find it by using a 5-yearly moving average, and then show that these points are valid there. Okay. Similarly, you have another question here where you need to determine the value of trend, a 3-yearly moving average, and then find the short-term fluctuations for various years assuming additive model. Well, if you remember, in our previous sessions we had talked about the additive and the multiplicative model. Okay, so here assuming additive model, you need to find the short-term fluctuations and then plot the original and the trend value on the same graph. Alright, so that's all we have for this session. Keep watching Edupedia World videos. We will solve these questions together maybe in our next session. Thank you.